From marine biologist Ocean Ramsey, this rare sighting of a great white tells the real story of the ocean's fiercest predator. She was absolutely magnificent, a perfect 9-foot female great white shark. Not a single mark on her pristine white belly or scarred dorsal fin. When marine biologists first spotted her cruising the waters off Western Australia, they knew they had found the ideal specimen. In the ocean, there's always supposed to be a bigger fish. When they encountered the enormous predator and captured the dramatic interaction on film, but we thought the great white was that bigger fish, the ultimate apex predator. Nothing hunts a great white shark. That all changed in 2003 when researchers tagged this female and gave her the code name Shark Alpha. 4 months later, her tracking tag washed ashore on a remote beach. The data it contained was absolutely impossible. The tag had recorded a sudden temperature spike from the frigid ocean depths to 78 degrees Fahrenheit. Then came a terrifying 1,900-foot plunge straight down into the abyss, complete darkness. And the most chilling part, the tag had recorded Shark Alpha's final moments from inside something's stomach. What could possibly devour the ocean's most feared predator? Shark Alpha represented everything marine biologists love about great white sharks. At 9 feet long and weighing close to 1,000 pounds, she was a mature female in her prime. Her sleek, torpedoed body moved through the water with the kind of effortless grace that had made great whites the ocean's most successful predator for over 400 million years. The research team from the Commonwealth Scientific and Industrial Research Organization had been tracking great whites off the coast of Western Australia for years, but Shark Alpha was special. She was the perfect candidate for their new satellite tracking technology. The tag they attached to her dorsal fin was a marvel of engineering. This wasn't just a simple GPS tracker. The device monitored water temperature, depth, light levels, and acceleration patterns. Every time Shark Alpha surfaced, the tag would ping satellites and upload a treasure trove of behavioral data. For 4 months, everything went exactly as expected. Shark Alpha behaved like a textbook great white. She patrolled her territory along the continental shelf, making regular hunting runs to seal colonies. The data showed her diving to depths of 300 to 500 feet, typical for a shark her size hunting in those waters. Her movement patterns were predictable, almost routine. She'd spend days cruising the same feeding grounds, occasionally making longer migrations along the coast. Water temperatures around her stayed consistent with the seasonal patterns. Light levels matched her depth readings perfectly. The researchers were thrilled. This was exactly the kind of baseline behavioral data they needed to understand great white ecology. Shark Alpha was giving them an unprecedented window into the daily life of an apex predator. Then, on December 4th, everything changed. The morning data transmission came through like always, but when marine biologist Dave Riggs downloaded the information, he immediately knew something was catastrophically wrong. The numbers on his screen defied everything he understood about shark behavior. The tag was still transmitting, but Shark Alpha was gone. What the data revealed next would challenge everything scientists thought they knew about the ocean's food chain. The numbers staring back at Dave Riggs made no sense. He refreshed the data feed 3 times, convinced there had to be a transmission error, but the readings remained the same, and they were absolutely terrifying. At 4:04 a.m. on December 4th, Shark Alpha's tag recorded a water temperature of 46 degrees Fahrenheit, normal for those depths. Then, in the span of just seconds, the temperature spiked to 78 degrees. That's not ocean water. That's body temperature. The tag had somehow ended up inside a living creature's stomach. But here's where it gets even more disturbing. Immediately after that temperature spike, the depth readings went haywire. Shark Alpha's tag began descending rapidly, not the controlled dive of a hunting shark, but a dead drop straight down into the abyss. 300 feet, 500 feet, 1,000 feet. The descent didn't stop until the tag hit 1,900 feet below the surface. That's deeper than the Empire State Building is tall, and it happened in just minutes. The light sensors told an equally chilling story. Great whites typically hunt near the surface, where light penetrates the water, but Shark Alpha's tag recorded complete darkness, zero light penetration, the kind of absolute blackness you only find in the deepest parts of the ocean. The acceleration data was the final piece of the puzzle. Instead of the rhythmic swimming patterns typical of great whites, the tag recorded erratic, violent movements. Then nothing. Complete stillness at the bottom of the ocean. Riggs called his colleague immediately. When marine biologist Rachel Bradford saw the data, her first reaction was denial. "This has to be equipment failure," she insisted. "Sharks don't just vanish into other animals." But the tag was still transmitting, still sending data. If it had malfunctioned, it would have gone silent. Instead, it was telling them a story that challenged everything they thought they knew about ocean predators. The team ran every diagnostic they could think of. They checked the tag's calibration history. They analyzed the transmission patterns for signs of interference. They even considered whether Shark Alpha might have been caught by a fishing vessel and dumped overboard. Nothing explained the data. The temperature readings were too consistent to be a malfunction, the depth profile was too dramatic to be accidental, and the timing was too precise to be coincidental.
In the tracking software, they even built identical tags and subjected them to extreme conditions in the lab. Everything checked out. The tag was functioning perfectly. That's when Rachel Bradford suggested something that made everyone uncomfortable. What if it was orcas? Killer whales are the ocean's most intelligent predators. They hunt in coordinated pods, using strategies that would make military tacticians jealous, and they're known to prey on great white sharks. The evidence seemed to fit. Orcas are warm-blooded mammals with internal body temperatures around 78 degrees. They're capable of deep dives, though 1,900 feet would be extreme even for them. Most importantly, there had been documented cases of orcas attacking great whites off the South African coast. But here's where the orca theory started falling apart. Orcas don't swallow their prey whole. When they hunt great whites, they flip the sharks upside down to induce tonic immobility, then extract only the liver. They leave the rest of the carcass floating on the surface. The tag data showed no evidence of this hunting behavior, no period of disorientation or flipping, no time spent at the surface, just a sudden temperature spike and an immediate dive to the bottom. Plus, orcas are social animals. They hunt in pods and communicate constantly. If a group of killer whales had taken down Shark Alpha, there should have been other orcas in the area. Marine mammal monitoring stations had no record of orca activity in that region during December. The researchers were running out of conventional explanations. Every theory they tested led to dead ends. Every possibility they explored revealed new contradictions in the data. That's when Dave Riggs suggested something that nobody wanted to consider, something that challenged the fundamental assumption they'd been working under. What if the predator wasn't a different species at all? He asked during a team meeting. What if it was another great... In the tracking software, they even built identical tags and subjected them to extreme conditions in the lab. Everything checked out. The tag was functioning perfectly. That's when Rachel Bradford suggested something that made everyone uncomfortable. What if it was orcas? Killer whales are the ocean's most intelligent predators. They hunt in coordinated pods, using strategies that would make military tacticians jealous, and they're known to prey on great white sharks. The evidence seemed to fit. Orcas are warm-blooded mammals with internal body temperatures around 78 degrees. They're capable of deep dives, though 1,900 feet would be extreme even for them. Most importantly, there had been documented cases of orcas attacking great whites off the South African coast. But here's where the orca theory started falling apart. Orcas don't swallow their prey whole. When they hunt great whites, they flip the sharks upside down to induce tonic immobility, then extract only the liver. They leave the rest of the carcass floating on the surface. The tag data showed no evidence of this hunting behavior, no period of disorientation or flipping, no time spent at the surface, just a sudden temperature spike and an immediate dive to the bottom. Plus, orcas are social animals. They hunt in pods and communicate constantly. If a group of killer whales had taken down shark alpha, there should have been other orcas in the area. Marine mammal monitoring stations had no record of orca activity in that region during December. The researchers were running out of conventional explanations. Every theory they tested led to dead ends. Every possibility they explored revealed new contradictions in the data. That's when Dave Riggs suggested something that nobody wanted to consider, something that challenged the fundamental assumption they'd been working under. What if the predator wasn't a different species at all? He asked during a team meeting. What if it was another great
Water below the hunting grounds of smaller great whites. It waits, motionless, sometimes for hours, monitoring the movements above. When a smaller shark ventures into the right position, the giant launches a vertical attack from below. The strike is devastating. A 20-foot great white attacking from beneath can generate enough force to swallow a 9-foot shark in a single bite. The prey has no time to react, no opportunity to escape. One moment, it's hunting seals near the surface. The next, it's inside the stomach of a larger predator. This explains everything about shark alpha's data. The sudden temperature spike to 78 degrees matches the internal body temperature of a large great white. The immediate dive to 1,900 feet reflects the hunting behavior of these deep-water giants. They strike from below, then retreat to the abyss where they can digest their massive meal in safety. The stomach acid analysis was the smoking gun. When great whites digest large prey, their stomach temperature rises slightly above normal body temperature. Due to the increased metabolic activity, the 78-degree reading wasn't just body temperature, it was the temperature inside an actively digesting stomach. But here's the truly terrifying part. The size of the predator that killed shark alpha had to be enormous. Based on the speed of the temperature change and the depth of the subsequent dive, researchers estimated they were dealing with a great white over 20 feet long, possibly closer to 25 feet. That's bigger than most great whites ever documented by science. We're talking about a prehistoric-sized monster lurking in the deep waters off Australia, a super predator that treats other apex predators like snacks. The research team realized they'd stumbled onto something that challenged everything the public believed about great white sharks. These weren't just mindless killing machines, they were sophisticated hunters with complex social hierarchies. The biggest sharks didn't just compete with smaller ones for food, they ate them. And get this, the cannibalistic behavior seemed to be increasing. Analysis of historical data showed that shark-on-shark predation events had become more frequent over the past 2 decades. As traditional prey species declined due to overfishing, large great whites were adapting. They were turning to the only food source big enough to sustain them, other great whites. The implications were staggering. If large great whites were systematically preying on smaller ones, it could explain why great white populations were declining faster than expected. Scientists had blamed overfishing, habitat loss, and climate change, but they'd missed the biggest factor of all. The greatest threat to a great white shark wasn't human activity. It was another great white shark, a bigger, hungrier, more experienced predator that saw shark alpha not as a fellow apex predator, but as dinner. The ocean's food chain wasn't a pyramid.
great whites at the top. It was a ladder, and something massive was climbing toward the highest rung. The discovery of what killed shark alpha shattered one of marine biology's most fundamental assumptions. For decades, scientists had positioned great white sharks as the ultimate apex predator, the top of the food chain, the final boss of ocean ecosystems. That was a lie. The truth is far more disturbing. Great whites exist in a brutal hierarchy where size determines everything.
The ocean's most feared predator is actually prey for something even more terrifying. Larger, more experienced great whites that have learned to hunt their own species with surgical precision. And here's what keeps marine biologists awake at night. These superpredators aren't anomalies. They're not rare genetic freaks hiding in the deepest trenches. Analysis of tracking data from around the world reveals that massive great whites are operating in every major shark habitat on Earth. Off the coast of California, researchers have documented similar predation events. In South Africa, unexplained shark disappearances now make perfect sense when viewed through the lens of cannibalistic behavior. The Mediterranean, the Pacific Northwest, the waters around Japan, everywhere scientists look, they're finding evidence of shark-on-shark predation. The size estimates are staggering. Some of these apex predators appear to be pushing 30 feet in length. That's bigger than most great whites in the fossil record. We're not just dealing with large sharks, we're dealing with evolutionary throwbacks, living giants that represent what great whites were capable of becoming before human interference disrupted ocean ecosystems. But here's the most chilling revelation. These monsters aren't just surviving in the modern ocean, they're thriving. As smaller shark populations decline due to overfishing and habitat destruction, the largest great whites are adapting.